Workshop today, I've decided to pick on a couple of relatively new technologies that not everyone here might have had a chance to get hands-on with and to play with. So first, the two technologies they're both imaging systems. One is an imaging system which allows you to see bacteria in real time, so it's the Moleculite camera. And then I've got another imaging system that allows you to make wound measurements, repeated wound measurements, so that you can see whether you're winning or losing your battle with the size of the wound. So the Moleculite camera, to start with, it works on the principle that if you shine a light of a certain wavelength at bacteria, they fluoresce. There's a molecule in the bacterial cell wall, a porphyrin, which fluoresces, and that molecule isn't present in our cells, so you can tell the difference. Most of the time the fluorescence will be red. But there are certain bacteria who the porphyrin molecule is slightly different. It's a cyanoporphyrin, and they come back glowing greenish blue, so your Pseudomonas, for example. So for the first time, we're able to, in real time, look and see if there are significant numbers of bacteria present in a wound. And we found a few interesting things. For example, bacteria in the wound aren't where you think they might be. Often they're not in the wound. They're living in the periphery, in the intact skin, and they're sort of thriving on the exudate that the wound is pouring out. So that has implications for where you take your wound swab from, because we're probably swabbing in the wrong place. But this technology allows you to target the use of your antimicrobial dressing. Now, we use too many antimicrobial dressings. We think we use too many, because we're sort of erring on the side of safety. We'd rather, if there's a chance the wound might have a lot of bugs in it, it's safer just to treat them with an antimicrobial dressing and to prevent wound infection. What this allows you to do is to say straight away whether a wound is completely clean or whether a wound has got lots of bacteria in it. And the wounds that are completely clean, they might not need an antimicrobial dressing, but the wounds that don't, they definitely need one. So you're able to be a bit more intelligent in how you target your use of antimicrobials. The second technology, the ability to measure the size of a wound, and that by size I mean area and volume. This has come about because 3D technology, 3D imaging technology has become a lot smaller. So the new iPhone, for example, has a built-in 3D camera. And also, all the software has got a lot better. Combine the two, it means you've got a handheld 3D camera. Because it's 3D, it knows that it can work out the distance between the camera and the wound, and therefore it can work out the size of the wound and the volume of the wound. That means you don't have to touch the wound, you don't have to get a tape measure out. It'll tell you this wound has got an area of so many square centimeters. So that means that when that wound is seen for the next time, usually by a different person who's not seen the wound before, you're able to see whether that wound has got smaller or not, or whether it's got static. One of the problems in the NHS is that we're spending £5 billion a year on wound care, and there's not a lot of continuity of that wound care. So it's a different person doing the dressings every time. They don't realise that the wound has not changed for the last 6 weeks or so. By building an algorithm into the software, so that if the wound is the same size as it was 6 weeks ago, then something has to happen. That has to be flagged up. So we need to be doing something else. Whatever we're doing isn't working. We need to do something else. So again, by being more intelligent with knowing whether our interventions are working or not, we can introduce a new intervention which will hopefully get the wound healed. And by doing so, will save the patient a lot of unnecessary dressing changes, but also save the country a lot of money.